So let's have a look at inverse of exponential functions, or otherwise known as logarithmic functions. Now, logarithmic functions are the inverse of an exponential function. So what that means is if you have a line of y equals to x, it's going to be reflected along that line. So if you have a look, 0, 1 becomes 1, 0. And remember, whenever you have a reflection along the y equals to x line, x and y get swapped around, so 1a becomes a 1. Alright, now remember to find inverse functions, you swap your x and y values. So well, before we do that, it's asking us what's the domain of its inverse. So remember, if you have the range of the original function, it then becomes the domain of the inverse function. Oops, wrong one. So let's have a look at the range. The original graph, I might even start part C here and just draw the original. The original graph has a reflection on the x-axis, but otherwise everything else stays the same. The y-intercept of the original is 5 times 1 plus 3, which is 8. So we'll cross over like that. And this is shifted up by 3, so I should actually fix this a little. And there you go. So the range of this function is going to be equal to, you can see it starts from 3, but we don't include 3, remember, because it's an asymptote. It'll never ever cross the actual asymptote. So that means it will start from 3 going all the way up to infinity. So that means that the domain of the inverse is going to be 3 to infinity. Alright, part B. Form the rule of the inverse function, express the inverse as a mapping. All that's saying is we need to rewrite the notation up there by finding the inverse. So we have f of x equals to 5 times 2 negative x plus 3. So now let's swap our x and y's. So then we have x equals to 5 times 2 to the power of negative y plus 3. Swap the 3 over, divided by 5. Then from here we need to use logs. That's of the base 2, so we'll just rewrite it with log 2. So negative y equals to log 2 of x minus 3 over 5. So then y is equal to negative log 2 of x minus 3 all over 5. So then if we want to write out the mapping, we would have f of the inverse, and we write down the domain up here being 3 to infinity going to all the real values for f inverse being equal to what we have up there, which is negative log 2 x. I might rewrite this actually. I'm going to use a log here and separate this. So we have negative log 2 of x minus 3 minus log 2 5, sorry, plus log 2 of 5. Now, the reason why I did that is because when we're drawing the inverse function, we can use the x equals to y line, or we can just simply use this bottom one here to work it out. Now, we have a reflection along the y-axis because it's above what's it called? We have a reflection of a y-axis because there's a negative in front of a log. So that means that instead of it going, oh no, let's not do it that way. I'll just draw it as a reflection. Okay, so any x values become y's and y values become x. So see this asymptote here, it then becomes x equals to 3. I don't know if I crossed there actually. Let's have a look. Let's firstly work out where they intersect. That would be a good one to do. So if we have 5 equals to 5 times 2 to the power of negative x plus 3 equals to negative log 2 x minus 3 over 5. Putting this in the CAS, we get x equals to 3.46. What that means is the intersection of this graph happens afterwards, after where they intersect. So if we draw in the asymptote, we have x equals to 3. This is going to cross over and reflected, so you can see this is close to on the right hand side of the original graph, it's close to the asymptote, so it's like that. Then it's going to cross over at 8, 0. And the crossover point is at 3.46. And putting that into the CAS, we also have the crossover point's actually at the y equals to x line, so it's right there, sorry. 3.45, oh sorry, 46 as well. Alright, so the general form, similar thing. I'm not going to go through all the different terms. Whoops, forgot a bracket there. General form, always the same thing. Always with the same thing of the y and x dilations, and the general shape is on the right. You can see it's a reflected version of the other one, which I've shown you before. Alright, so sketch a graph of y equals to log 2, x plus 2 and state its domain. Now, remember the general shape is it's h being the vertical asymptote this time. We have a plus 2, which means our h is going to be equal to negative 2. Then now we need to solve for next intercept. So 0 equals to log 2 of x plus 2. So remember, you need to rewrite this in terms of an exponential. So 2 to the power 0 equals to x plus 2. Remember 2 to the power 0 is a 1. So we have x equals to negative 1. So cross at negative 1 and then head up. 1, 0. And then we also have a y-intercept here. So let's put in x equals to 0. Log 2 of 2 is equal to 1. So that's 0, 1. Part B. If we shift it up by 1, it doesn't actually do much, except for changing the y-intercept. So we just have to find the y-intercept. X-intercept. So 0 equals to log 10x plus 1. Log 10 of x is equal to -1. Rewrite this so that we have x equals to 10 to the power of -1. So then x is equal to 0.1. And then part C. The graph of the function is shown below. Determine the value of b. Alright, so we have to look at the shift reflections. Now you can see that the normal log goes this way, it's reflected back the other way. So that means there's a negative in front of the x, which we have here. Then our asymptotes actually shifted to 1, 0 instead of 0, 0. That means our value of b must be equal to 1 because it shifted to the right one. Okay, state the domain and range and form the rule for the inverse function. So domain of f, you can see what it is. It goes from -infinity all the way up to 1. The range of f is all real values. So then if we want to write it down as a rule, remember our range of the normal function becomes the inverse, and we also need to find the original. So f of x equals to log 2 1 minus x. Switch our x's and y's, so then we have x equals to log 2 of 1 minus y. Rewrite this in terms of power, so we have 2 to the power of x equals to 1 minus y. Subtract the 1 over, and then take the negative. So then our rule would be the inverse going from the range, which is real, to real, and then f inverse of x is equal to 1 minus 2 to the power of x. And then if we're sketching the inverse, that's a reflection on the y-axis, and then it's shifted up by 1. So then shifted up by 1. Oh, whoops. Hang on, sorry. So we'll cross at 1, 0. And then we need to work out the y-intercept because that's not worked out there. Is it worked out? Oh, that is worked out. Oh, sorry, that's meant to be a 2. Whoops. That changes a lot, actually. Whoops. Just change all the 1s to 2s. And then we'll also cross at 0, 1.